Okay, good afternoon, year 10. Today we will start with our last unit of physics, that is atomic physics, and we will talk about the atom, subatomic particles, and radioactivity. Okay? Remember, this is chapter P22 in your book. Alright. Okay, let's first start about the atomic structure. An atom consists of a small nucleus, and the nucleus is composed of neutrons and it is surrounded by electrons. Okay? Now, before we are even going to talk about these subatomic particles, I just want you to realize how small a nucleus is. Now, if I would consider the board as the complete size of an atom, then the size of the nucleus, I do it with red, would be like this. Can you see it? Well, hardly, no? Meaning that actually the nucleus is very, very tiny compared with the volume of the atom. So actually, the atom is virtually empty. Okay? Now, let's look at the particles. We have here the nucleus, and in the nucleus we have the protons and the neutrons. And around the nucleus, in shells or orbits or orbitals, we have the electrons. Okay? So, because an atom is neutral in charge, and you know, you have learned in electricity, static electricity, that when you have a plus charge and a negative charge, they will cancel each other out. Yeah? So, for example, in this case, we have 1, 2, 3 protons. That would make 3 plus. Because it is neutral, we need to have 1, 2, 3 electrons. Yeah, these are positive and these are negative. Yeah, and then plus 3 plus minus 3 is 0. So the atom is 0. Just a small question, and you know that from chemistry. What will happen if the amount of electrons are going to change and the amount of protons stay the same? Well, if we would add 1 more electron, then the atom becomes a negative ion, or when we just remove 1 electron, that means that the atom would be ion positive. Okay? Just as a small reminder. Okay? Now let's look at some properties of the subatomic particles. By the way, I will put it back for a moment, just so that you make some notes. Just pause the video, make a note, and then move on. Alright? Okay, let's look at the atomic mass number. Okay? The atomic number, or the proton number of an atom, is equal to its protons. Yeah? And the protons actually will decide which atom or element we are talking about. So when we have a proton number 1, we are talking about the first atom in the periodic table, that would be hydrogen. And the next one would be helium, lithium, etc. Okay? The mass number, or the nuclear number, of an atom is equal to the number of protons plus neutrons. Okay? So, the mass of an atom mainly depends on the mass of the nucleus or the nucleons, the protons and the neutrons. Okay? We may say that actually the mass of an electron is virtually negligible. Yeah? It has no effect or hardly any effect on the mass of an atom. Alright? Well, in this case we have 3 protons, 4 neutrons and 3 electrons. Okay, so the lithium has an atomic mass of, indeed, 3, and the mass number will be 7. Okay? Don't forget this. Okay? Again, pause the video and make some notes. Okay. Now let's look at some other properties of the protons, neutrons and the electrons. Okay? Now, the protons. Where do we find the protons? We find the protons in the nucleus. Okay? What would be the relative mass of the proton? That is 1. What would be the relative electric charge? That is +1. When we look at the neutron, where do we find the neutron? In the nucleus. The relative mass of a neutron is equal to the relative mass of a proton is 1. Now, neutron sounds like neutral. So, one of the reasons why we call it a neutron is that it has no charge. Then, let's look at the electron. Where do we find it? We find it outside the nucleus, and it has a relative mass of 0.05, or we may say it is negligible. Okay? And what is the charge? -1. Okay? So, again, the mass, or the relative mass of an atom is defined by the protons and the neutrons. The relatively charge is defined by the protons and the electrons. And remember, when we are talking about an atom, the amount of protons is equal to the amount of electrons. Okay? Again, pause the video and make a note of this. Okay, how do we do the nuclear notation? Well, first notation is the number of protons plus protons. Yeah? Then we denote the element. And this 6 is denoting the amount of protons. Okay? So, on the top, protons plus neutrons. And only protons in the bottom. And that we also have to denote, of course, chemical symbol, right? Now, take into account that when this number is going to change, the element is going to change. Yeah? If we go from 6 to 7, we go from carbon to nitrogen. So, when the proton number changes, everything changes. It's a different element, different chemical properties, etc., etc. Okay? the proton number, the atomic mass number can change, for example, by changing the neutrons, the amount of neutrons. That means that the atomic mass changes. It doesn't mean always that this number has to change, but only the mass changes. Okay? Again, pause the video and make a note of that. Alright? Now we are going to talk about isotopes. I mentioned it a little bit. Isotopes are actually atoms of an element. They have always the same amount of protons. However, they have different amounts of neutrons. Okay? For example, we have 3 isotopes of hydrogen. We have hydrogen 1. And hydrogen 1, interesting, hydrogen 1 only has 1 proton, 1 electron. So if we would write down the notation for hydrogen, well, proton number, protons plus neutrons is 1. The overall charge is 0 because we have 1 plus and 1 negative. The next one we call deuterium, and now a neutron is added. Now how would we write deuterium? Does the proton number change? No. But does the mass change? Yes, proton plus neutrons, so that means it's 2. Overall charge again is 0. Then we have tritium, still hydrogen. So only 1 proton. Hydrogen 1. How many protons and neutrons do we have together? 3. Yeah. So in this case we have 3 different types of isotopes, yeah, of hydrogen. And there are actually some applications for tritium and deuterium. Okay? So, when we want to describe the 3 isotopes, we may say hydrogen 1, hydrogen 2, and hydrogen 3. Okay? Make a note of that, pause the video, and then we move on. Alright, now I have a question. An isotope of uranium, chemical symbol is U, consists of 92 protons and 143 neutrons. How can we name this isotope? Well, we know that the element name is uranium. Now we have to find the mass number of the uranium. And the mass number is the amount of protons and neutrons, which make it 235. So we can denote this element as uranium 235. Okay? Why can we say uranium 235? Well, if we talk about uranium, it only has one specific amount of protons. So we know that. Only the isotope can be different, and which is determined by the amount of isotopes, by the neutrons, which can change. Okay? But from here, we can actually determine, looking at the periodic table, find the element uranium, you find the protons, and then you can find the amount of neutrons by doing the atomic mass minus the protons, and then you find the amount of neutrons. Okay? Then the other way of notation, and we said that before, we can do it like this. Yeah? 92 protons, atomic mass 235, amount of neutrons plus protons. Okay? Again, pause the video, make a note, and then we move on. Okay. Let's look at this question. So I would recommend you to pause the video now and you determine the number of protons and neutrons in the isotope table. So pause it, write it out, and I will give you the numbers. Okay. For number 1, protons 7, neutrons 6. You know what is this one? That's cobalt. 27 protons, number of neutrons 60 minus 27. Next one, Au, you know what is Au? That is gold. Protons is 79 and the amount of neutrons is 179 minus 79 is 118. Then the last one, plutonium. Plutonium has an amount of protons of 94 and neutrons 239 minus 94 is 145. Okay? Look at it and listen to the song and then we move on. This is actually your wake-up call when you normally are having your lunch sleep, okay? It's a good wake-up call song. Okay. Meanwhile, I want to move on, and now we are going to talk about radiation and what is the effect of radiation. Really? Taking so long? Oh my God! All right. Just one interesting note, I will speak a little bit louder. What we can see here clearly, when we have large atoms, you will see that the amount of neutrons is way more than the amount of protons. And this is for the simple fact to stabilize these atoms. Now, just to remind you that actually the heavier or the bigger the atom becomes, the more unstable it becomes. Okay? Now, when it becomes more unstable, it will fall apart and give off energy in the form of radiation. And that's what we are going to talk about No. So, all right. But first we need to know what we mean by ionization. Okay? Ionization occurs when an atom gains or loses one or more electrons. Okay? So, when an atom is losing an electron, it becomes a positive ion. Okay? Again, we can look at the structure. Yeah? This is lithium, uncharged. When we take away one electron, it becomes +1. Okay? Another type of ionization is when an atom is gaining an electron and it becomes a negative ion. You will later see when you go to the A-level chemistry, we give it a little bit different name. Okay? Now, this ionization has an effect on your atoms in your body. Yeah? And when you are exposed to radiation, it can actually ionize your atoms in your body, and you could get mutation, and as a cause of that mutation you could get cancer. Okay? Now let's look a little bit at the radioactivity and ionizing radiation. The nuclei of some isotopes, as I mentioned already before, are unstable and they decay. When this decay is happening, they give off radiation. Okay? So this is happening at unstable atoms. Okay? Now this phenomenon is called radioactivity. And the radiation that is produced, we call it ionizing radiation. Yeah? It has the property of ionizing atoms. Okay? Radioactivity is a random process, and we will talk about that not in this slide, but in the next slide when we are talking about the half-life of radiation. Okay? So, the decay of an atom is not really predictable, but only over a long term. Okay? And this Monsieur Henri Becquerel, who actually discovered the radioactivity. And when you want to denote the amount of radiation, it is announced in Becquerel. Okay? Now we're going to talk about the 3 types of radiation. So again, make a note of that, pause the video, make a note, and then we move on. Right. 3 types. Alpha, beta, and gamma. These come from the Greek letters alpha, beta, and gamma. Alpha, we write it like this. Beta, we write it like this. And gamma, we write it like this. Okay? Alpha. Alpha consists of 2 protons and 2 neutrons. And that's it. That means the alpha particles have a charge. And they radiate out. Yeah? Alpha particles are strongly ionizing. So that means they have the tendency of ionizing atoms in your body. However, they are the least dangerous, which we will talk about. And we have the beta. Beta is actually a high-speed electron, so it has a negative charge. Okay? And the last one, oh wow, we'll talk about that, yes, sorry. It is produced when a neutron decays in an electron and a proton. So we get actually a neutron produces a proton and an electron, and is that this electron that actually is radiating, and that is what we call the beta radiation. Okay? Moderately ionizing, but they have a much higher speed than alpha, okay, and can penetrate a little bit more. Then the last one, interesting, because this one is actually the most dangerous one. Yeah, gamma rays have a very high frequency. Because they have a very high frequency, they have a lot of energy, and they are just like light, electromagnetic wave. They behave just the same as light. However, their ionization is the lowest. Yeah, they are weakly ionizing, and they are produced when an unstable nucleus loses energy. Okay? Now we're going to talk about why, while these are weakly ionizing, they are still the most dangerous radioactive particles. Okay? So again, make a note of this, pause. And then we move on. Okay. Now we are going to look, and now you will understand why gamma radiation is so dangerous. We're going to look at the penetrating power of the alpha, beta, and the gamma. Okay? Now, just to remind you, alpha 2 plus has a charge of 2 plus, beta has a charge of -1. Okay? Let's look how alpha and beta can penetrate. If we just have a paper or a few centimeters of air, it will stop the alpha. And now you will understand actually why alpha radiation is not so dangerous, despite the fact that it has a high ionization rate. Beta particles, they will go through its high speed, and gamma particles will go through the paper. Then we have 1 centimeter of aluminum, 1 meter of air, and that will actually stop the beta radiation. Okay? But the gamma radiation is still penetrating. This goes straight through the aluminum foil. And now you will understand that despite the fact that the ionization of gamma is very weak, the penetration rate is very high. We only can stop gamma radiation of a thick plate of lead or a meter of concrete. Well, 1 meter of concrete, that's even bigger than thicker than the walls we have here at school. Now, you might have gone to check your bones if you maybe broke a bone, or maybe check your teeth, and X-rays are more or less similar to gamma rays, And X-rays have actually a very high penetration rate. So people who are working there, they use special material. They have like a lead vest, and you might have noticed when you go to the doctor, you needed to have an X-ray. That the people, they go out of the room and they make a photo of your teeth or your bones. No, you are only exposed for a couple of milliseconds to gamma radiation, so that won't hurt your body. However, if you would work in an environment constantly make those photos, you would be exposed for more time in gamma radiation, X-rays, and then you could get cancer. Yeah? So, as a safety precaution, these people, they are going out of the room. These rooms have special protection. Sometimes they have a lead wall, or they have a very thick concrete wall. Okay? Now, make a note of this. So, we have discussed now that ionization, alpha highest, beta medium, gamma low. Now we look at the penetration. Alpha very, very low, beta a little bit more, but gamma just goes straight through your body. You can only be stopped by lead. Now, how do the radiation, when we have radiation, how do they behave when we put them in a magnetic field or in an electric field? Now, I said already, alpha has a charge of 2 plus, beta has a charge of minus 1, the charge of gamma is 0. So let's look how the different types of radiations deflect in a magnetic field. Alpha, positive charge. And this is interesting to see what is going to happen, how they deflect. Now, why do we have all those sounds? Okay. Okay, what can we make up from this? Now, alpha has a positive 2 charge. However, alpha contains 2 protons and 2 neutrons. In mass, this is way more than in mass of the beta. Yeah? The mass of beta is maybe 1/10,000th of the mass of this. So, when you have like a particle going here, and yes, the charge is bigger than the beta, but the mass is way bigger, so the deflection is less than we would see in the beta. Yeah, see them turning around. Gamma, no charge, goes straight through, not deflected by a magnetic field. Okay? So, alpha and beta particles are deflected, remember, because they have different charge. Alpha is positive, so in the sound field it goes up, beta it goes down. Yeah, so they are pushed in the opposite direction, and the gamma is going straight through. Yeah? So, because of the larger mass of the alpha particles, they are deflected far less. And gamma rays are not deflected because they are not charged. So they cannot be deflected. Okay? Make a note of this. Now, for the deflection of an electric field, again, alpha 2 plus negative 0. And let's see how they behave in the electric field. Well, on the top we have negative, and on the bottom we have positive, so the electric field is this way, which you will learn in the A level. Now, the alpha is plus, so it is attracted to the negative plate, so it's going to bend upwards. Okay? The beta particle is negative, so it's going to bend to the positive plate. Remember from electrostatics, plus and minus, they do attract. And again, gamma is going straight through. Alpha and beta particles are deflected in opposite direction due to their opposite charges. Due to the much larger mass of alpha, are deflected less than beta. And the gamma, they go straight through, and they are, because they are not charged. Okay? Okay. To finish up this slide, okay, we are going to fill in the sentences and just stop it for a moment and then try to fill in. So I give you a couple of 10 seconds to pause the video. All right. Atoms of a very small nucleus containing protons and neutrons surrounded by electrons. Atoms of the same element will always have the same number of protons, but different amount of different isotopes of the same element will have different numbers of protons. The atoms of some substances are unstable and radioactive. They may give off alpha or beta particles or gamma ray particles. Gamma ray particles are the most penetrating type of radiation, is the least. Yeah? Okay. Now, for this video, please make a note of everything. We will finish atomic physics by next week. So we have done all the physics topics, yeah? And just to remind you that next week you have to finish all the questions of end of chapter P21, okay? Next time we are going to talk about the different decays, yeah? The alpha decay, beta decay, and the gamma decay, okay? So, ciao!